Hello dear students, I welcome you all again in this lecture of managerial economics. I have already discussed about the total revenue and total cost approach of a business firm, that how a business firm can earn maximum profit, how a firm should know about the optimal level of output, how much units of output the firm should produce in order to get maximum profit. In this lecture, I am going to discuss with you about the marginal analysis. So, optimization by marginal analysis, that how the basic theme of this topic is that how a business firm can maximize its profit level by using the analysis of marginal. So, marginal analysis means the tools of marginal cost and marginal revenue. Marginal analysis means the concepts of marginal cost plus marginal revenue. Keep one thing in mind, that in economics or in managerial economics, marginal cost is denoted by MC. Marginal cost is denoted by MC, and marginal revenue is denoted by MR. So, for the optimization analysis, by the means of marginal revenue and marginal cost, we can also find out the optimal level of output where the business firm can get maximum profit. So, marginal analysis is one of the most important concepts in economic theory in general and in optimization analysis in particular. In optimization analysis, we are also using the concepts of marginal cost and marginal revenue instead of total cost and total revenue. According to the marginal analysis, the firm can get its maximum profit at a point where the marginal cost equals marginal revenue. When the marginal revenue equals marginal cost, it means that the firm can get maximum profit at that point and the output level will be the optimal. So, according to this approach, a business firm maximizes its profit when total revenue equals total cost. A business firm maximizes its profit when total revenue equals total cost. That is, when marginal revenue that a firm earns after selling its output in the market equals marginal cost. At this point, profit will be maximum. Pi is the symbol which we use for profit. This is the notation which we use for profit in economics and also in managerial economics. So, marginal analysis uses the concepts of marginal revenue and marginal cost in order to find out the optimal output level where the business firm can earn more profit, maximum profit. So the question is, what is marginal cost? What is marginal revenue? So let me define both terms. Marginal cost. It is the change in total cost per unit change in output, per unit change in output. It is the change in total cost. I am talking about the concept of marginal economics. It is the change in total cost per unit change in output. We can also say that the change in total cost divided by the change in output, that is, marginal cost is equal to change in total cost divided by change in output. Change in total cost divided by change in output. It means that if there is a change in a unit increase in output level, how much change will occur in the total cost? The ratio of both these relationship, both these terms is known as marginal cost. What about the concept of marginal revenue? Marginal revenue can be written as marginal revenue. It is the change in total revenue per unit change in output. It is the change in total revenue per unit change in output or sales. That is, marginal revenue is equal to change in total revenue divided by change in output or sales. Q stands for sales or output. TR mean total revenue. Total revenue of a business firm. So this is the concept of marginal revenue. We can also say that marginal revenue is the slope of the total revenue curve. Marginal revenue or marginal revenue is the slope of total revenue curve. Marginal revenue is the slope of total revenue curve. Similarly, we can also say that marginal cost is the slope of total cost. So in the marginal analysis, we are using the concepts of marginal revenue and marginal cost in order to find out the optimal level of output where the firm can get maximum profit. According to this approach, according to the approach of marginal analysis, as long as the slope of total revenue curve exceeds the slope of total cost, it fails for the firm to expand output and sales. This is a simple guideline. If this is a simple rule, guideline or rule. If the slope of total revenue greater than slope of total cost, it means the firm should produce more units of output in order to get more profit, in order to get maximum profit. If the slope of total revenue means marginal revenue, is greater than slope of total cost. Slope of total cost means marginal cost. We can also write it as, if marginal revenue is greater than marginal cost, the firm should produce more units of output up to the point where marginal revenue is greater than marginal cost. This is the basic guideline. It means that the firm should expand its output and sales. On the other hand, it means that the firm would be adding more of its total revenue than its total cost. So the total profit would increase. If marginal revenue is greater than marginal cost, it means by expanding total units of output, the firm should expand its output level. If the firm expands its output level, it means there is addition to total profit. Simple. If marginal revenue of a product is greater than marginal cost, the firm should expand its output level. The firm should sell more output. So by increasing more units of output, there will be an addition to the profit, to the total profit of that firm. And that was the case when Q was equal to 1 in the previous example, and Q was 3. The marginal revenue was greater than the marginal cost at that point. If vice versa, if the slope of total revenue is less than the slope of total cost, or if marginal revenue is less than marginal cost, what will happen? The firm would be adding less of its total revenue. The firm, if this is the case, I mean to say that if marginal revenue is less than marginal cost, this is the opposite case of this one. This is the opposite case of this one. If marginal revenue is less than marginal cost, what will happen? There will be less addition to its total output, to its total profit. At Q3, when, as we have seen in the previous graph, when Q was 3, marginal revenue was equal to marginal cost. When marginal revenue is equal to marginal cost, this is the maximum profit level. Maximum, it means profit will be maximum. So according to the marginal analysis, according to the marginal analysis, as long as the marginal benefit of an activity, marginal revenue means marginal benefit of an activity exceeds the marginal cost of that activity, it fails for the firm to increase an activity. It means the firm should increase its output level in order to get the maximum profit. So, if marginal benefit marginal benefit means marginal revenue is greater than marginal cost of that activity, the firm should increase its output. For what purpose? In order to get maximum output. It means that the firm at this level is having no optimal output level. The firm should expand its output level up to the point where the marginal revenue is equal to marginal cost. So, if the marginal revenue or marginal benefit of an activity exceeds the marginal cost of that activity, the firm should produce more output level in order to get maximum profit. Now, optimization, the topic is optimization with calculus, that how we can use the concepts of differential calculus in order to get maximum profit level. So, mean optimization with calculus. In the previous example, we have shown the maximum profit level by the means of total revenue and total cost approach and marginal revenue and marginal cost approach, that how a business firm can earn maximum profit by using marginal analysis as well as total analysis graphically. Now, we are using the concepts of calculus, we are applying the tools of calculus in order to find out the optimal output level where the firm can get maximum profit. So, optimization often requires finding the maximum or the minimum value of a function. The maximum or a minimum value of a function. The maximum will be in the case when the firm is interested to earn maximum profit. The minimum point of a function includes when the firm interested to minimize its cost. So, maximum in terms of maximum profit, minimum in terms of minimum cost. For example, a firm may want to maximize his profit, or a firm may want to minimize its cost. So, for a function to be at its maximum or minimum, the derivative of the function must be 0. For knowing the maximum and minimum point, this is the important point. For maximum and minimum, first order derivative of a function is 0. For knowing the maximum and minimum point, first order derivative of a specific function is 0. For example, dy by dx, this must be 0. This is called first order derivative. First derivative or first order derivative for a maximum or minimum point, the first order derivative of a function must be 0. For example, we have a function total revenue. Total revenue function is 100 km minus 10 Q square. This is the total revenue function, where total revenue totally depends on the number of units that a firm produces. So total revenue equals 100 Q minus 10 Q square. Taking first derivative with respect to Q, change into total revenue due to change in Q, d by dq of 100 Q minus d by dq of 10 Q square. We get 100 minus 20 Q. This is the first order derivative, 100 minus 20 Q. Now setting this first order derivative equals to 0, setting it equal to 0, that is change into total revenue, change into Q equal to 0. Why? For finding the maximum or a minimum point. So equal to, setting it equal to 0, we can get it. $100 minus 20 Q equals 0. Solving it for Q. So minus 20 Q equals minus 100, minus minus will be cancelled out. So 20 Q equals 100. Q is equal to 100 divided by 20. Q will be 5. It means number of units must be 5. What does it mean? It means that if a firm wants to earn maximum total revenue, he or she must produce 5 units of its output. At this output level, he can get maximum total revenue. So for the maximum and minimum, this function, total revenue function, we set it equal to 0, and from there we can find out the equilibrium output level or optimal output level where the firm can get maximum total revenue. Now there is a difference between a maximum or a minimum. How we will know about the maximum point and a minimum point? So distinguishing between a maximum or a minimum, the derivative of a function or curve is 0 at both the maximum and minimum point. This is one issue, that is derivative of a function is 0 at a maximum or minimum. Derivative of a function is 0 at a maximum or at a minimum. Then how we will know that this is a maximum or a minimum point? There is a confusion in knowing the maximum and minimum points. So for finding the maximum and knowing the maximum and minimum point, we use the second order derivative. It means the derivative of the derivative. We will use the concept of second derivative. Second derivative means the derivative of a derivative. It means we are differentiating the first order derivative at second time. For example, if, and we denote it by this, like we say that for the first order derivative that dy divided by dx is equal to 0. This was the first derivative, or specifically change into total revenue due to change in output equals 0. This was the first order derivative. Now for the second order derivative we use this symbol, d square total revenue divided by d q square. This square stands for second order derivative. It represents the second order derivative. So the second order derivative may be greater than 0. This is one possibility. Or this second order derivative may be negative, less than 0. If this is the case, the second order derivative may be positive or negative. If d square y divided by dx square, or in terms of economics, d square total revenue divided by d q square, if it is greater than 0, what does it mean? It means positive. If second derivative of a function is greater than 0, then x is a minimum, then x is a minimum. This function shows the minimum point, x is a minimum. But if y due to dx square, the opposite case, if this is less than 0, it means that x is a maximum. So the problem is solved now. If the second derivative of a function is greater than 0, it means it signifies that x is a minimum point. If the second derivative is less than 0, it means x is a maximum. For example, we have a function that y is equal to x cube. Cubic function, we have a cubic function, y is equal to x cube. So what will be the first derivative? The first derivative will be change in y due to change in x is equal to 3x square. This is the first order. This is the first order derivative. What about the second order derivative? Second order derivative means derivative of this one, derivative of the derivative. It will be 6x. This is called second order derivative. Now let me give you a specific example, then you will know about the, for example, this is total revenue is equal to 100 q minus, let me put this example again, the total revenue function. Total revenue is equal to 100 q minus 10 q square. So first derivative is change into total revenue divided by change into q. this is equal to 100 minus 20q. 100 minus 20q. This is the first order derivative. For knowing the output level setting, change into total revenue due to change in output equals to 0. That is 100 minus 20q equals 0. So minus 20q equals minus 100, q is equal to 5. Q is equal to 5. So for the maximum revenue, the firm must produce 5 units of output. Now we are looking that is this function is positive or negative for a maximum or a minimum. We will take the second derivative. So second derivative of this one is d square total revenue divided by d into q square. We will take second derivative of this one. So this one, it will be minus 20. The answer is minus 20, and we know that minus 20 is less than 0. It is a negative value. The second derivative of the total revenue function is having negative value. If it is negative value, it means maximum. What does it mean? It means that for a maximum total revenue, the firm should produce 5 units of output. For a maximum total revenue, the firm should produce 5 units of output. And the graphical analysis, we have already shown that, for example, this is the output level, this is the profit. This was the profit function. Derivative is actually the slope of a function, while the second derivative refers to the change in the slope of a function. First order derivative is equal. First order derivative means slope of a function. Second order derivative means change in the slope of a function. So the value of second derivative can be used to determine whether we have a maximum or a minimum at the point at which the first derivative is equal to 0. So this is the basic concept we can use. So the profit function has a 0 slope. This is 0 slope. Here slope is 0. What does it mean? It means that change in profit due to change in Q is equal to 0. And this was the case when we produce Q1. For example, if this is 3, so when Q was 1 or Q was 3, the slope of that specific function was 0. In the neighborhood of Q equal 1, in this area, the slope of the profit function increases from being Q less than 1. This is Q1 less than 1. This is increases, reaches up to 0, then positive. So the profit function faces up, and we have a minimum. We have a minimum less than when Q was less than 1, increasing. Here 0, positive. Here was negative, 0 and positive. So the profit function is minimum at Q is equal to 1. In the neighborhood of Q is equal to 3 in this area. When Q was equal to 3, the slope of the profit function decreases. Look at here. The slope of the profit function decreases. This is the minimum. Then again increases. So in the neighborhood of Q is equal to 3, the slope of the profit function decreases. The slope of the profit function decreases. What does it mean? It means the second derivative, like profit change into Q square, less than 0 because it is decreasing. From being positive first, then 0, this is the 0 level, and then negative, so that the profit function faces down and we have a maximum. Similarly, we can also put another example, that is total revenue let me write another example. Total revenue is equal to 45Q minus 0.5Q square. This is the total revenue function. Taking first derivative, change into total revenue due to change in Q is equal to Q minus with respect to Q, 45 minus Q. So setting this expression equal to 0, change into total revenue, change into Q equal to 0, we can find out Q is equal to 0, like 45 minus Q equals to 0, Q is equal to 45 units the firm should produce. So for the second derivative, change into total revenue, change into Q square of this function, 45 minus Q, this is equal to minus 1, which is less than 0. What does it mean? It means that this total revenue function reaches a maximum at Q is equal to 45. It means that this total revenue function reaches its maximum point when the firm produces 45 units of output. Thank you so much for joining me. That's all for today. In the next lecture, we will be talking about the multivariate optimization, that if we have more than 2 variables, how we can analyze the optimization problem, how we can find out the optimal output level where the firm can earn maximum profit. Thank you so much for coming. Goodbye.